Hello everyone, welcome to the series of GPAT MCQ. Today's topic for discussion is coarse dispersion. This is Trupti Parab. First question, how might solid sodium carbonate be obtained from the sodium carbonate solution? Option A, centrifugation. Option B, filtration. Option C, evaporation. Option D, it cannot be extracted. So the correct answer is option C, evaporation. In the sodium carbonate solution, the solid is molecularly dispersed in the solvent throughout the solution. Thus, neither centrifugation nor filtration may be used. Heating the solution and evaporating the water will help us to yield a solid sodium carbonate. Basically, the sodium carbonate solution is nothing but a true solution or a molecular dispersion in which the sodium carbonate is evenly dispersed into the solvent, and that is the reason this is the monophasic solution, and heating the solution will help us to evaporate the water which is acting as a solvent, and it will help us to yield a solid sodium carbonate. Now let's move on to the next question. What is the best description of a blood? Option A, sol. Option B, foam. Option C, solution. Option D, aerosol. So the correct answer is option A, sol. Blood can be separated by centrifugation, so it's not a solution. The continuous phase is liquid, so it cannot be aerosol. The dispersed phase is mainly solid, so it's not a foam. Blood is best described as a colloidal suspension or a sol. So here in this chart you can understand the type of solution at the type of sol and their dispersed phase and dispersion medium. Basically, liquid aerosol, for example, the dispersion medium is a gas and the dispersed phase is a liquid. So basically, the liquid droplets or liquid particles are dispersed into the dispersion media, where gas is a dispersion media, and the example of liquid aerosol is a fog. So basically, sol, the blood is best described as a colloidal suspension, which is also known as sol. Next question. A suspension is formed from uniform particles of a solid of a diameter 10 micrometer suspended in a solvent. What is the best description of this system? Option A, monodisperse and coarse. Option B, monodisperse and colloidal. Option C, polydisperse and coarse. Option D, polydisperse and colloidal. So the correct answer is option A, monodisperse and coarse. As mentioned in the question, the particle size is uniform in nature, so this dispersion is not polydisperse. So the correct answer is monodisperse, and the particle size is greater than 1 micrometer. As mentioned in the question, it was 10 micrometer. So this is not a colloidal suspension. In this chart, you can see the difference between the molecular colloidal and coarse dispersion sizes. The size for coarse dispersion is more than 1 micrometer, and that is the reason the given suspension is monodisperse and coarse in nature. Next question, which one of the following dispersion does not have liquid continuous phase? Option A, nano suspension. Option B, microemulsion. Option C, gel. Option D, foam. So the correct answer is option C, gel. Nanosuspension, microemulsion, foams have a solid, liquid, gaseous, dispersed phases respectively. However, they each have a liquid continuous phase. So what is continuous phase and what is dispersed phase? Basically, the external phase is known as continuous phase and the dispersed or suspended phase is known as internal phase. Like in this picture, you can notice the continuous phase as well as the dispersed phase. Gels have a liquid dispersed phase, but the continuous phase is solid. So what they want to say that कि जो हमारे gels होते हैं, pharmaceutical gels, उनका dispersed phase liquid होता है. That is the internal phase, while the external phase is solid. Next question, which one of the following system has the smallest size domain in its dispersed phase? Option A, true solutions. Option B, coarse suspension. Option C, coarse emulsion. Option D, microemulsion. So the correct answer is option D, microemulsion. Let's understand the solution in detail. Coarse dispersion have larger domains than colloidal dispersion. So in previous question we studied the size range of molecular dispersion, coarse dispersion and colloidal dispersion. We all know that the coarse dispersion have a larger size that is greater than 1 micrometer, and that is the reason they have a larger domain than the colloidal dispersion. Microemulsions are colloid with a particle size which are smaller, that is micro in size, while the true solution are defined as a molecular dispersion in which solid is dissolved in a solvent due to which they are monophasic in nature. So जो true solution का option है वो emit होगा. So microemulsion has the smallest domain size in a disperse phase. Dispersion और disperse phase का concept कहाँ पे applicable होता है? जहाँ पे system biphasic होगी nature में. For example, emulsion. Two immiscible liquids, oil in water, we try to suspend the molecules of oil in a water and vice versa. So in this case, the microemulsion has the smallest domain size in a disperse phase. Move on to the next question. Which of the following sequences correctly describe the change in a domain structure as more oil is added to a water and oil emulsion? Option A, bicontinuous, spherical, cylinder-like. Option B, spherical, cylinder-like, bicontinuous. Option C, spherical, bicontinuous, cylinder-like. Option D, cylinder-like, spherical, bicontinuous. So the correct answer is option B, spherical, cylinder-like, bicontinuous in nature. नॉर्मली या जनरल लेमैन टर्म में बाइकंटिन्यूअस माइक्रो इमल्शन को मिडल फेज ऑफ इमल्शन भी बोला जाता है while the bicontinuous micro emulsion are basically interdispersed oil and water separated by the flexible surfactant monolayer. लाइक हम यहाँ पे देख सकते हैं कि यहाँ पे माइसेल जनरेट हुआ है बट यहाँ पे एक ये लेयर है मोनोलेयर फॉर्म हुआ है एंड why we are using surfactant because these two are completely immiscible with each other. तो surfactant को एक सर्फेक्टेंट को दोनों एंड होते हैं पॉजिटिव एंड भी होता है नेगेटिव एंड होता है दैट इज अ हाइड्रोफिलिक भी होगा लिपोफिलिक भी होगा हाइड्रोफिलिक हेड एंड लिपोफिलिक टेल एंड वो सर्फेक्टेंट हेल्प करता है कि दो इमिसिबल चीज़ों को वो एक दूसरे में डिस्पर्स होने के लिए हेल्प करता है सो दैट इज द रीजन बाइकंटिन्यूअस स्ट्रक्चर फॉर्म होने से पहले वो स्पेरिकल डोमेन था एंड आफ्टर एडिशन ऑफ ऑयल इट बिकम्स सिलेंडर and the bicontinuous structure is formed. Next question. The scattering of light by the coarse and colloidal disperse system is known as option A, contrast matching, option B, DLVO theory, option C, Tyndall effect, option D, creaming. So the correct answer is option C, Tyndall effect. The scattering of light by the coarse and colloidal disperse system is known as the Tyndall effect. Tyndall effect is also known as a Tyndall phenomena in which scattering of a light takes place by the medium containing small suspended particle. अब यहाँ पे आप देख सकते हो कि जब लेजर बीम की लाइट को पास किया प्योर वाटर से तो लाइट बीम इज नॉट विजिबल as well as it is not scattered because there is no suspended particles present in a pure water. While when we try to pass the laser beam or light through the colloidal solution, we can see the light beam is visible as well as scatter due to the presence of small suspended particle and this is known as Tyndall effect which is also known as Tyndall phenomena. Next question. Which of the following is not a mechanism for the separation of a physically unstable suspension of a magnesium hydroxide in water? Option A, flocculation. Option B, aggregation. Option C, Oswald ripening. Option D, hydrolysis. So the correct answer is option D, hydrolysis. Magnesium hydroxide does not undergo hydrolysis when in a solution. Hydrolysis represents a chemical transformation while flocculation, aggregation, Oswald ripening all represent the physical changes takes place into emulsion as well as suspension. Oswald ripening is an irreversible process in which it involves the growth of a large droplet at the expense of a smaller one. Creaming is the upward movement of a dispersed droplet of emulsion relative to the continuous phase such that they concentrate at the top. So creaming is basically upward phenomena. उसमें क्या होता है कि जो dispersed droplet थे वो basically upward movement करके concentrate होते हैं at the top layer पे मतलब जो अगर सस्पेंड लाइक इमल्शन या इमल्शन को तुम अगर सेटल डाउन हुए और अगर तुमको ऐसा दिख रहा है कि जो डिस्पर्स फेज थी वो पूरी ऊपर आके अक्यूमुलेट हुई है, सो दैट इज द क्रीमिंग बेसिकली। एंड इसको एक इंस्टेबिलिटी बोलते हैं, फिजिकल इंस्टेबिलिटी, क्रीमिंग, flocculation, breaking of emulsion, phase inversion. This is the characteristic to oil in water emulsion as oil are less denser than water. So basically oil की density कम होती है, so oil accumulate होके ऊपर float करता है and we can consider this as a creaming. Flocculation is a weak reversible association between emulsion droplet which are separated by the trap continuous phase. बेसिकली फ्लॉक्स मतलब छोटे छोटे फ्लॉक्स फॉर्म्स होते हैं एंड ये एक वीक और रिवर्सिबल फिनोमिना है, मतलब वीक होगी उसकी बॉन्डिंग कि अगर दो मॉलिक्यूल्स दे आर ट्राइंग टू गेट अट्रैक्ट, बट फ्लॉक्स कैसे होते हैं, बेसिकली दे आर रीडिस्पर्सिबल, मतलब तुम शेक करोगे तो वो फ्लॉक्स एकदम नॉर्मल हो जाएंगे. Each cluster of droplet floccules behave physically as a single kinetic unit, although every droplet in the floccule retain its individuality. These are reversible, that is, they can be redispersed easily by agitation. So basically, shake करने के बाद जो floccules form हुए हैं, वो redisperse होके suspension या emulsion ठीक हो सकता है. So basically it's a reversible phenomena. मतलब कैसे होता है, breaking of emulsion, it's a irreversible phenomena. अगर emulsion break हुआ तो हम कुछ नहीं कर सकते. We have to discard the emulsion. Here in this diagram you can notice, देखो ये एक normal emulsion है जहाँ पे ये oil के droplet disperse है water के अंदर. तो देखो अभी ऑयल पार्टिकल्स है तो वो दे आर ट्राइंग टू गेट लाइक, मतलब एक वीक फोर्स है जो उनको कनेक्ट करने की कोशिश कर रहा है, सो इसलिए वहाँ पे फ्लॉक्यूल्स फॉर्म हुआ है. सो दिस इज अ फ्लॉक्यूलेशन एंड सेडिमेंटेशन, बिकॉज अगर वो ड्रॉपलेट्स हैवी है तो सेटल डाउन होंगे, तो दैट इज अ सेडिमेंटेशन. अगर उनकी डेंसिटी के ऊपर डिपेंड करता है तो वो क्रीमिंग, की डेंसिटी लो है सो दे आर फ्लोटिंग गेटिंग अक्यूमुलेटेड. सो सेडिमेंटेशन इज अ डाउनवर्ड फिनोमिना एंड क्रीमिंग इज अ अपवर्ड फिनोमिना. एंड ऑस्वल राइपनिंग में तुम देख सकते हो कि कैसे वो लार्ज मॉलिक्यूल्स फॉर्म हुए हैं, मतलब वो फ्लॉक से कलेक्ट होके लार्ज ये फॉर्म हुआ है. एंड ये कोएलिसेंस में आप क्लियर कट देख सकते हो कि कैसे मतलब एक लाइक सब लाइक ये चारों जो स्टेप्स थे, लाइक चारों स्टेप्स नहीं, आई एम सॉरी, ये चारों जो लाइक फिनोमिना थे, इंस्टेबिलिटी, फिजिकल इंस्टेबिलिटी, वो आगे फर्दर जाके कोएलिसेंस में होगी. एंड कोएलिसेंस में बेसिकली क्या होगा, वो होता है ना कि जो उनका कोहेसिव फोर्स है, वो कोहेसिव फोर्स की वजह से ऑयल इज गेटिंग अट्रैक्टेड टुवर्ड ऑयल एंड वाटर इज गेटिंग अट्रैक्टेड टू वाटर, एंड दैट इज द रीजन बेसिकली द फेज आर गेटिंग सेपरेटेड, मतलब फेज सेपरेशन हो गया. सो वी वर ट्राइंग, मतलब विद द हेल्प ऑफ इमल्सिफाइंग एजेंट या सर्फेक्टेंट वी वर ट्राइंग टू डिस्पर्स ऑयल एंड वाटर या वाइस वर्सा, बट बिकॉज ऑफ द इंस्टेबिलिटी we get the separated phase, मतलब हमें दोनों separated phase मिल चुके हैं. and this indicates that the emulsion should be discarded. phase separate हुआ तो ये मतलब discard करना चाहिए. Thank you for your attention. Stay tuned for more such videos.